In this video, we will talk about using the 10 steps to analyze a quadratic function. Now, we see that a typical quadratic function in standard form is f of x is equal to ax squared plus bx plus c. And what we want to do, first thing, is to find the domain. Now, the quadratic function is a type of polynomial function that has a degree of 2. What makes it quadratic because it's has a parabolic shape because of the degree of 2, x squared in this case. But ax squared plus bx plus c is the standard form of a quadratic function, and it has the same characteristics when finding a domain of a polynomial function, which in this case will be from negative infinity to positive infinity. So the domain will be from negative infinity to positive infinity for this type of function. So when finding the domain of a polynomial function in standard form, you have these characteristics of the polynomial with that same type of shape, but of the degree 2 here. All polynomials have a domain from negative infinity to positive infinity, or all real numbers. Number 2, we want to determine the concavity. So when you have this type, ax squared plus bx plus c equal to f of x here, since a, this coefficient term, or this coefficient of the term, a is greater than 0 for this type of function, the graph will concave upward. Now, for f of x is equal to negative x squared plus bx plus c, since in this case a is less than 0, the graph will concave downward. And we see that less than 0, that means basically when you have a negative value for the coefficient, for the leading coefficient of the leading term. Up here is a positive coefficient for the leading term. So a greater than 0 will have a graph that concaves upward. When a is less than 0, you have a graph that will concave downward. So number 3, the vertex is going to equal to negative b over 2 times a, whatever value that is of the x component. To get the output of the y component, you're going to plug the x component into the original function, and that's going to give you your output. And so you'll have your vertex, which has an x component, y component. And we'll later talk about, for the x component of the vertex will be its axis of symmetry. And of course, the y component, which is the output here of the vertex here, will be the minimum slash or maximum value depending upon its concavity. Number 4, you have the vertex form of the parabola f of x is equal to a times x minus h squared plus k. Well, now the x and the y component of the vertex on this step now becomes h and k. So that'll be plugged in here to give us the vertex form of the parabola, which also is known as the transformational form of the quadratic function, because this will make it much easier to graph using the horizontal transformation. And of course, Here, this will be the vertical transformation. Number 5, the axis of symmetry, like we said, mentioned just a few seconds ago, that the x component of the vertex is considered the axis of symmetry, whatever the value is, and it cuts the graph in halves. Number 6 would be the minimum maximum value, and that's the y component of the vertex, right? Number 7, we want to find the x-intercept, so we substitute 0 in for y equals an f of x, because y is the same as f of x. And we solve for x, or we just simply set the function equal to 0. And then, of course, solve for x. Number 8, we want to find the y-intercept by substituting 0 in for x, and then solve for y. And then 9, we want to graph f of x. When we graph f of x, we're going to plot the vertex. We're going to also plot the x-intercept and plot the y-intercept. And lastly, we'll find the range of the function. Please take the time, pause the video, and copy all of the steps, because we're going to do a problem and we're going to work through all of the steps to analyze the quadratic function. Let's look at an example. F of x is equal to x squared plus 4x. So the first step we want to use, or the first step we want to do, is find the domain. So let's find the domain. And this is very simple because the quadratic function is a type of polynomial. The type of polynomial it is a polynomial of degree 2. So in this case, one of the characteristics of a polynomial for finding the domain of a polynomial function is that the domain of this type of function, and quadratic function as well, is going to be all real numbers. All real numbers, so the domain is going to be from negative infinity to positive infinity, or if we write it in set builder notation, we can say that the set of all, that's what these braces mean, the set of all x such that x is equal to all real numbers. All real numbers. Okay? So that's what we have for the domain of this function. Number 2, what do we have? Number 2, we're looking for the concavity. So when we find the concavity, we're going to consider, as we said, now in this case, we see that A is equal to 1, B is equal to 4, and C is equal to 0. These are good things to write down for the next part of the steps, right? But considering that A is greater than 0, we see that, right? That A is greater than 0, so that means that the function is positive. The function is positive. It's gonna concave, in this case, concave upward. It's going to have a minimum value. And the range for this type of problem, since A is greater than 0, the range is going to look like this, where you have the y component of the vertex, whether the y component is going to be all the way to what? Positive infinity for this type of problem. So in this case, we can sketch, give this a small, make my line a little bit straighter. This sketch doesn't have to be, detailed per se, but just give some idea of what the graph is going to look like when we actually graph it in the ninth step of the analysis. Okay, so it's going to basically look like this. It's concave upward, and it's going to have here, folks, a minimum value. And as you can tell, whatever this value, minimum value is, going all the way up to what? Positive infinity. This is going in the positive direction. You see that? So that's the analysis of your concavity of this function. Number three, we want to look at finding the vertex. And when we find the vertex, we see from the previous step that we label A is equal to 1, B is equal to 4, and C is equal to 0. So the x component, let's write out the formula. Let's write out the formula here. So we have the vertex. It's going to be negative B over 2 times A. And then, of course, whatever that value is, that will go back into the original function. So x is equal to negative 4 over 2 times positive A, positive 1, which is going to be negative 4 over 2, which in this case, your x component is going to equal to 2. So x is equal to 2 here in this case. So we say y is equal to f of negative 2, plugging that into the original function. So negative 2 times negative 2 is positive 4, and then plus 4 times negative 2 is going to be negative 8. So our y component of the vertex is going to be negative 4. So here, the vertex here, in this case, is going to be equal to negative 2 and negative 4. So everybody see that? So our next step is going to be to find the vertex form of a parabola. So the fourth step, the vertex form of the parabola. And we have f of x is equal to a times x minus h squared plus k. Now watch. We see that a is equal to 1 and that b, well, in this case, well, let me make mention of this so we won't confuse everybody out there. We know from the last step, step number 3, that the vertex is -2 and -4, which is the x component and the y component. Now, in this step, in this step, in this step, in this step, the x component, and y component becomes h and k. Now it becomes h and k. So in other words, the x component of the vertex, the x component of the vertex, the x component of the vertex, the x and y component of the vertex now becomes h and k, which now this here is going to, now h is going to equal to -2 and k is going to equal to -4. Okay, so that's very important here, right? So for this step, this is number 4 continuing. We have f of x is equal to 1 for a, x minus -2 square plus -4. So now I want to clean this up. So here, f of x is going to equal to, and this is going to understood to be 1 there on the outside of this parenthesis, x plus 2 square minus 4. This is your vertex form of the parabola, folks. This is the vertex form of the parabola. Explaining that to you in detail. Everybody see that? Number five, we're finding now the axis of symmetry. Y'all remember this? What was the axis of symmetry? From, giving you an overview of the 10 steps. Well, it's the x component of the vertex, which is going to be x is equal to -b over 2 times a. Well, what was that value? That value was going to be what? The value is x is equal to what? -2. So -2 is the axis of symmetry, which it cuts the graph in half. You see, -2. Number 6. What was number 6? Number 6, we need to find, is it a minimum value or maximum value? Well, it's a minimum value because a is greater than 0 and it concaves upward. So you have a minimum value which equals what? -4. -4. Okay, take this time to pause the video, and copy all these steps down very thoroughly and get an understanding of these steps so far, and then we're going to continue with number 7, and number 7 is going to be finding the x-intercept. So pause the video and copy down these steps. Okay, step 7, we want to find the x-intercept. And what we talked about earlier in the overview of the 10 steps. Number 7, we just simply plug in 0 for plug in 0 in place of f of x or y. Y is equal to f of x, which is the same. Y and f of x is the same. Or just set this function x squared plus 4x equal to 0, and then we factor or find the roots. We factor and find the roots, right? Or you can use the quadratic formula, but this is very, very, very simple. So we factor out dx equal to 0, and then we set, of course, x is going to equal to 0, solving for x, and then you have x plus 4 is equal to 0. We're taking negative 4 to both sides. So x is going to equal to negative 4. So our x-intercepts here in this case going to equal to, and always write your intercept, always write your intercepts, your y-intercepts, your x-intercepts and your y-intercepts as coordinates. Good math habits, right? So negative 4, so negative 4 is 0 and 0, 0 are your x-intercepts. Number 8, we want to find the y-intercept. So what we basically do is plug in 0 for x and then solve for y. So f of 0 is going to equal to 0 squared plus 4 times 0, which this is going to equal to 0. So our y-intercept in this case, our y-intercept is going to equal to 0, 0. Number 9, what do we do? Number 9, step 9, we actually graph f of x. We graph f of x, so we want to plot the vertex, the x-intercept, and the y-intercept. So when we do this, what do we have? Actually, what do we have? We have this is going to be 0, 0. This is going, and also negative 4, 0. This is going to be 0, 0. Oh, whoa, whoa, wait a minute. Oops, made a mistake. They wrote them in the wrong place. I'm sorry. Let me go back and glad we caught that. Okay. Going back. The vertex here is going to be negative 2 and negative 4. There we go. Now the x-intercept is going to be 0, 0. There we go. And negative 4, 0. And this is going to be 0, 0. So we're ready to plot the graph of f of x. X and y. So 1, 2, 3, 4, 5. Say 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So basically, we know this is 1, 2, 3, 4, and of course this is -1, -2, -3, -4, -5, and of course this is going to be -1, -2, -3, -4, and of course this is 1, 2, 3, 4, so forth and so on, right? So let's use this color, and we're going to plot the vertex -2 on down to +4, which is right here. Okay. Then what do we have? We have 0, 0 for the x-intercept. And then we have 4, -4, 0 right there. And our y-intercept is also 2, 0, 0. So we draw a nice smooth curve, parabola through these points. And so we see that right here, this being -2 and -4, which the minimum, excuse me, the minimum occurs at -2, but it is, the minimum value is -4. It is -4, occurring at -2. Things always occur at x, but it is the y value. Remember that. And so that this right here is going to be 0, 0. And this is right here is -4, 0. So we have our f of x. This is the graph of f of x. Y'all see that? Okay. Our last step here is to find the range. And we can see that from -4 to +infinity. So number 10, the range and we know that that's going to be the y component, the range being for this function, type of function, because a is greater than 0, the y component going to +infinity. So the range in this case, your answer to solution to here, is going to be from -4 to +infinity. So this is how you analyze a quadratic function using the 10 steps to analyze its behavior and what's going on within these 10 steps. And this is a real good analysis on how to observe or study uh, the quadratic function techniques. But here, these 10 steps gives you a complete overview on the analysis and behavior of the quadratic function. So, if you will, subscribe to my YouTube channel, and I will see everyone in the future. Thank you.